Thank you. So before we get started, I just wanted a show of hands if you currently test whatever app you're working on. It can be in Java or Kotlin, I don't mind. So that's about 3/4 of us. Now, could you leave your hand up if you would release your app to production without opening it on a phone first? Not even me, right? And if we were talking about APIs, this would be a very different story with our continuous delivery now. So I'm going to take a look at our journey trying to get to continuous delivery of the apps and what testing approach we've found has helped us to kind of get on the way there. As you can tell, we're only almost there. We're not quite there yet. But let's take a look at it. So if you've got an app, I'm sick of to-do apps, so this is today's example. It gets succulent pictures from Reddit. So if you've got a given app, how are we going to test it? So I'm going to take a look at what and when you should be testing, some unit testing basics for Kotlin because it is a bit tricky, UI testing the debug build, and then something interesting, which is UI testing the release build that you've already proguarded. And so that means you can test the actual APK that's going onto the Play Store. We have smoke tests for our APIs. We should have smoke tests for our apps. So if we start with what to test, hopefully we're all familiar with the testing pyramid, right? You want lots of unit tests and only a couple of end-to-end tests. So if we start at the bottom and have a look at what you want to test at each stage, your unit tests are really focusing on logic and edge cases. You're trying to capture every conceivable thing that could happen to your class and test it in isolation. What you're not trying to do is test your libraries. You're not trying to test your frameworks. Those things have already been tested. So keep your unit tests to your own code and try to keep logic out of Android framework classes as well, because they're difficult to unit test. So try to get your logic out of your activities, out of your fragments, so that you can test it without Roboelectric and without that overhead. Then we move up to integration tests, and there's two different types of integration tests for Android. You've either got Roboelectric tests that spin up your view kind of in a virtual environment, it's not an emulator, and they're lightning fast, or you've got Espresso tests which run on a real phone or an emulator, and they're a bit slower. What's actually coming out soon is Roboelectric 4, and that's going to let us run Espresso syntax on Roboelectric. And so for the purpose of today's talk, I'll be focusing on Espresso tests, because pretty soon it'll cover both cases. Finally, you've got end-to-end tests. And so in Android, we do that by black box testing our app, even after it's been proguarded, and you can do that with UI Automator and some Gradle configuration. Now, at Seek, there's actually one more step to this, and it's public beta. So what I want to make clear here is you're never going to catch every bug with a test suite. It doesn't matter how good your automated testing suite is. Don't set that as your goal, because you're just going to be disappointed. We're trying to catch the most bugs with the minimum effort. So if you can catch 80% of your bugs, you're doing pretty well. So, yeah. So if that's what you should be testing, when do we think we should be testing this? The answer is as you go. Now, I'm not going to advocate TDD for Android. I don't think it actually works that well. But what you should at least try to do is every commit that you're making, commit a couple of tests alongside it. And there's a few reasons for this. It's going to help you abstract your dependencies early on. And it's also going to make your code have, better design choices, testable design choices. But the other thing is it's going to stop you from hating tests, right? If I ask you to do anything 50 times in a row, you're going to hate it. So why would you want to leave it to the end and write 50 tests in a row? Don't do that to yourself. Do it iteratively. All right, so let's move on to some unit testing. So unit testing in Kotlin, there's a few basics. You want to write lots of small tests. You really shouldn't store any state in between your tests. That's just standard testing practice. That means that if you run just one test or all of the tests, they're going to behave the same way. That's very important. And you want to use mocks or stubs to isolate the class under test. So if you're new to testing, a mock is something that kind of pretends to be another class, so that if you've got a class and dependencies, you're only testing the class and you're not testing the dependencies. And so it helps us isolate what we're actually interested in. So if we look at the shape of a unit test, there's a couple of important things here. And the first one is that I'm using latent init for both the thing under test and also its dependencies. And then that lets us actually create the instance in the setup step. And what's important about this is you get a new instance for each test case, so it's impossible to store state in between your tests. So that's going to keep your unit tests really deterministic. You can use Mockito annotations to do this as well. I prefer this syntax, but that's up to you. The important thing is to use latent init. And then even if you're doing this, you're going to get some errors when you start writing Android tests for the first time. So the first error you'll probably run into is Android class blah, blah, blah has not been mocked. You know, your fragment's not mocked or your log is not mocked. You've got two options here. They're not, like Android framework classes aren't available to you during unit tests. So you can either abstract around them so that your test can mock them, or you can use Roboelectric, which is going to mock all of the Android classes for you by default. It's your choice. It depends what you're testing, but do be aware that this isn't only for UI. It's things like log, 2base64, and the URI class. So this can pop up in unexpected places. The next error that you'll probably run into is getting that you can't mock final classes, at least with Mockito. So you could bring in PowerMock at this point, but it's kind of a jackhammer. And as of Mockito 2, you actually can mock final classes. It's marked as an experimental feature at the moment, but it works pretty well. We've been using it for about 3 months. And then you don't have to worry about the fact that all your classes are final in Kotlin. So I've just linked the instructions there, and you can follow that if you're interested for Mockito. And the last thing you're going to get is null pointers. And this will be a problem with pretty much any mocking library, because at the moment, they're all written for Java. So all of your little stub methods, all of your matches return null, because they can. So the way that we're fixing this at the moment is to use a shim that sits on top of Mockito. It's called Mockito Kotlin. And it just gives you nicer syntax as well as returning actual objects from the matches. So you're not going to get null pointers from Kotlin. So it makes your code look a bit nicer. So this is with plain Mockito. And with Mockito Kotlin, we've just got better syntax and we're not escaping those keywords as well. So that'll set you up to run your unit tests pretty well. And I've just included a list of my favorite matches here that you should use. This covers pretty much every test case in our app. We've got almost 1,000 of them. And there's just one call out. Don't use argcaptor. It's been confusing our developers, and the syntax is a lot easier to read if you mock that with whenever, then answer, rather than using an argcaptor. It just keeps your tests a bit easier to understand. So if we move on to UI testing now, for UI testing the debug build, we're going to use Espresso. We're also going to try not to store state between our tests again, but it's a bit harder this time because your app is naturally going to want to store state. You've got databases, you've got shared preferences, your app's all about saving the user's state. So you have to explicitly clear that out, either before your test starts or in between tests. You need to be smart about what you're going to test because these are slower. So you don't want to test everything or you'll be waiting a really long time. So pick your user flows carefully and use mock sparingly this time. So instead of mocking everything, only mock at like a bare minimum level. I recommend at the networking OK HTTP level, because what that's going to let you do is if you refactor your code base and you've mocked these low enough, you actually keep these tests because all they hit is the UI and the network, and you can change anything in the middle and keep your test suite. That's really, really valuable for making sure that you know your refactor didn't break anything. So we'll be using Espresso, UI Automator, Mockito Kotlin, and Mockito Android as well. So one note, Mockito can't mock final classes on the Android JVM. So even though you can mock them for your unit tests, anything that you want to mock in your UI test does have to be either an interface or an open class. So if we have a look at the structure again, at the top, we've got the activity test rule. And there's a parameter here that's really important, which is launch activity false. Don't launch your activity straight away because that runs before you have a chance to inject your mocks. So what I'd actually recommend is launching your activity in each test case, and that allows you to have the before method where you can inject your mocks, just like with your unit test. Otherwise, you'll find your app making real network calls and it just becomes a pain to clean up. So with mocking at the network layer, there's lots of options for you. These are just some of the common libraries. There are many more. Mock web server is pretty simple. It just queues up responses and returns them in order. Otherwise, OK Replay is a bit more complex, or you can even write your own mocking interceptor as well. But what you will want to use is OK HTTP idling resource. And that's a library that kind of automatically gets Espresso to wait for your network call to return so that you don't have to do fred.sleep or try again until it's on the UI. It'll just stop the test, wait for the network call to come back, and then keep going. And it's kind of like 2 lines of code, so I'd really recommend it. The next thing is animations. Disable animations during your test run. Don't leave them turned on. They will lock up the testing framework. And even if you do turn off animations, we find that loading spinners will still keep going. They tend to ignore the animation flag. So I've included as well some testable loading spinners that just stop that from happening. Yep. The last one, or not the last one actually, but taking screenshots is something else that we often want to do. So there's a special folder to save your screenshots on Android for test screenshots, and that means that any device farm is going to pick them up. If you're using the Google Cloud or if you're using AWS device farm, they automatically search this directory. But there's also a lot of screenshot libraries, but what they don't usually cover is granting you the permission to save the screenshot, which is going to mess with your UI tests because it's a dialog. So I would use a helper method to kind of accept that permission and save the screenshot. And again, that's included in the code base, which I'll put the link at the end again as well. Custom view matches or view assertions. So Espresso is really kind of extensible, and that's good because it has some trouble matching recycler views and nested scroll views. And also if you've got any custom views that you've written, it may have trouble matching them as well. But you can write your own view assertions and your own view matches. So I've included one for recycler views as well. And finally, when should you use UI Automator? So something a lot of people I've not heard much is you can actually use Espresso and UI Automator in the same test. You know, one line after the other, it's fine. They work together really well. And we use this for things like verifying notifications. So if you're going outside the scope of your app and you need to check that some integration with Android is working properly, you can actually use UI Automator for that, even in your Espresso test. It is kind of a last resort though. It tends to be more flaky than Espresso and harder to work with. So keep it as a last resort, but you do have that up your sleeve. So talking about UI Automator, let's get on to testing our release build. So you really only want to have a couple of these tests. They are smoke tests. They're going to run on your production systems because you don't get a chance to put any mocks in. So whatever data you're using, it's production data. Pick one test device for this. So with your Espresso tests, I would run them on a lot of devices, but with UI Automator, just pick one device that is your smoke test device. It's not worth trying to make it work on every Android version. Finally, we can use a Gradle parameter to configure this, and that's what I'll cover now. So this is the setting, and it's not widely documented, but if you change your test build type to release, then you can actually run on the release APK all your UI tests. Now, the Espresso tests are just going to fail, but if you've written your tests in UI Automator, they should work. We use a Gradle parameter for this, which helps us compile it on the command line. And the interesting thing about that is you can't compile your debug test and your release test in the same command. It won't work. So just be aware of that. You do have to run two separate compilations on your CI tool. And just some tips for using UI Automator. Use wait for exists. It's not as forgiving as Espresso about waiting for the UI to calm down. So make sure you write that into your test. Target by ID or by text. Those are kind of your only two options because it is black box testing. So UI Automator has a minimum SDK of 18. But if you need to run like your Espresso tests on older phones, you can just add an override and make sure that you only run your UI Automator tests on newer phones. And finally, keep your tests in a separate package so that you can target them. So I like to have a debug package and a release package, or however you want to split them up, so that you can target which test package you want to run. And that's pretty much it for today. So any questions?